Good morning, Trig. We are going to cover lesson 85. And so if you have your Trig Identities sheet, that would be great. If not, I have recorded the 3 identities we're going to be using. They're under the title Pythagorean Trig Identities, and there's 3 of them. And so we're going to be using these identities today. So we're going to be solving trig functions. So there's a lot of review in here. Solve 3 times tangent squared theta equals 7 secant theta minus 5. And for all of these, given that 0 degrees is less than or equal to theta, which is less than 360 degrees, right? This is the domain we are going to be working with like normal. All right, so first things first, I'm going to recognize that I can replace the tangent squared of theta so that I can include this proof. So I can replace that to be 3 times, if I subtract 1, I get secant squared of theta minus 1 equals 7 secant theta minus 5. So notice I've replaced the tangent, so now my entire equation will be using just secant. So I'm going to distribute the 3 and put it all on one side, factor, and solve. So 3 secant squared theta minus 3 equals 7 secant theta minus 5. So I'm going to get it all on one side. So 3 secant squared theta minus 7 secant of theta plus 2, right? Because I would have to add the 5 equals 0. Now I'm going to factor. So the first number times the last, I have 6. The middle number is negative 7, so that'd be negative 6 and negative 1. And then I'm going to have to do bottoms up because I have a 3 out front, so I'm going to divide each by 3, and my factors are the secant of theta, negative 6 divided by 3 is negative 2. And for this next one, I have the secant of theta minus 1/3 equals 0. So now I'm going to solve for each of these, right? I have the secant of theta minus 2 equals 0, and the secant of theta minus 1/3 equals 0. And then we'll solve. So this is, when does the secant of theta equal 2? When does the secant of theta equal 1/3? All right, so let's talk about secant is the reciprocal of cosine, right? So this is 2 over 1. So these are reciprocal functions. So I'm going to draw, let's see here, all students take calculus because that helps. Also, I have a 1 and a 2 and a 1 and a 3. So let's start with this side. So this is, when does the cosine of theta equal 1 over 2? Well, that would be 60 degrees because it's positive in these 2 quadrants. So 60 and 300. And so I use cosine because it's the reciprocal. So secant will be positive in the same 2 quadrants. So this is, when is the cosine of theta equal 3 over 1? And if I'm using my special right triangles, I know I have a root 3, but this hasn't been squared. So there are no solution that I get a perfect 3 divided by 1. So my 2 solutions for theta are theta equals 60 degrees and theta equals 300 degrees. So we're going to practice a couple like this just to get you familiar with factoring these complex trig functions in order to solve. So number 2, I'll do it in a different color. Solve 2 sine squared of x equals 3 plus 3 cosine x. Now, the reason I'm replacing one of these is because right now I have 2 different trig functions. I have sine and cosine. And so I need to, if I'm going to factor this, they have to be the same. So I'm going to replace sine squared x using this first theory, I know that if I subtract cosine, then the sine squared of theta equals 1 minus cosine squared of theta. And so that's exactly what I'm going to do. I'm going to replace it with, this would be 1 minus the cosine squared of x equals 3 plus 3 cosine x. So now I just replaced what was in yellow, but now everything's in terms of cosine. So I'm going to go ahead and distribute. I get 2 minus 2 cosine squared x equals 3 plus 3 cosine x. And I'm going to get everything on the same side so that I can factor. So I'm actually going to move everything to the right. And so I get 0 equals 2 cosine squared x plus 3 cosine x. And I would subtract 2, so plus 1. All right, so first times the last, so I'm going to factor. So 2 times 1 is 2. Middle number is a 3. Factors of 2 are 2 and 1, but I'm dividing by the 2 out front. So my factors are the cosine of x plus 1, because 2 divided by 2 is 1, and the cosine of x plus 1/2, and then equals 0. So I'm going to set both of these equal to 0. So when does the cosine of x plus 1 equal 0? When does the cosine of x plus 1/2 equal 0? All right, so I'm going to divide. So I'm solving for when does the cosine of x equal a -1? When does the cosine of x equal a -1/2? So again, all students take calculus, and I'm going to draw that 1, 2, √3 triangle. And so when does the cosine equal? I'm going to start with the 1/2 because I get 1 over 2, which would be 60 degrees. But I'm negative in quadrants 2 and 3. And so that would be 180 minus 60, which is 120 degrees, and 180 plus 60, right? I'm talking about these two quadrants. And so that is 240. So over here I get 120 and 240. And I probably should mention this is an x, which means they might want it in radians, and we can do that in a minute. But when does the cosine of x equal -1 over 1? Well, if it's just a 1, I know it's a quadrantal angle. So this is 1, 0, 0, 1, -1, 0, 0, -1. Now I know cosine is x value. So the coordinate, that has an x value of -1 would be this guy right here, right? And that is 180 degrees. So I have 3 answers, 180, 120, and 240. Okay? All right. Moving on. Next one. So solve 2 tangent squared theta equals secant theta minus 1. And I'm going to do a couple on here just so you have the examples. So I want to make sure this is all in the same trig function. So I'm going to replace this using my 3 properties. Tangent is involved here. So the tangent squared of theta equals secant squared theta minus 1. And so that's what I'm going to replace here. Right? So I've got 2 times the secant squared of theta minus 1 equals secant theta minus 1. I'm going to distribute. I'm going to get it all on one side. And then I'm going to factor. So first number times the last number. Middle number, this is an invisible -1. So -2 and +1, but I have to divide by the first number. And so my factors are the secant of theta minus 1 and the secant of theta plus 1/2 equals 0. Now hopefully we can skip the step where we set it equal to 0 and subtract. So I'm solving for when does the secant of theta equal a 1, and when does the secant of theta equal a negative 1/2. Now, it's very similar to the last one. Secant is the reciprocal of cosine. All students take calculus. So this is 1 over 1. So when does the cosine of theta equal 1? Well, that would be the x value here at 1, 0, so at 0 degrees. Okay. Over here, I've got, again, 60 degrees, but it's negative in these two quadrants, so 120 and, oh, whoops, sorry. When does the cosine of theta equal negative 2 over 1? Remember the reciprocal functions. And so the cosine never equals 2 over 1 because it's adjacent over hypotenuse. So this has no solution. There's no perfect, you're not going to get a perfect negative 2. So the only solution was 0 degrees. All right, we're only going to do one final problem, and we will be done with these notes. So last one, solve root 3 cotangent squared of x plus 2 cotangent x minus root 3 equals 0. Now, this problem is already in a single trig function. So I don't have to look at the properties because I already have cotangent all the way across. And it's all on one side. So I get to just go straight into factoring. The top should be root 3 times negative root 3, which would give me negative 3. The middle is a 2, so that would give me 3 and negative 1. But then I would have to divide by the root 3. So my factors are the cotangent of x plus 3 over root 3 times the cotangent of x minus 1 over root 3. And I'm setting this equal to 0, so now I'm going to set both of them. I'm going to subtract. So when does the cotangent of x equal negative 3 root 3? When does the cotangent of x equal 1 over root 3? And I'm going to start with this one. So 1 root 3, that would be 30 degrees. But when is it positive? All students take calculus and these two. So 30 degrees and 210, right? Because this quadrant here would be 180 plus 30 degrees. And in this quadrant here, it would just be 30 degrees. You're always looking for those related angles. Now for the left, oh, whoops. You guys, this is embarrassing. This is cotangent, which means when is the tangent of x root 3 over 1? Ay, ay, ay. I forgot about the reciprocal functions. Cotangent of x of 1 over root 3 would be the same as the tangent of x of root 3 over 1, which would be 60 degrees. So that would give me 60 degrees and 180 plus 60 degrees, which is 240. All right, for the other, I have a negative 3 over root 3. Now, this one's a little complicated. In order for me to kind of figure what angle this came from perfectly, I'm going to rationalize it. And so that gives me the cotangent of x equals negative 3 root 3 over 3, which equals negative root 3 over an invisible 1. So this is asking when is the tangent of x a negative 1 over root 3. Well, it's negative. This would be the 30 degrees. There's 1 root 3. And all students take calculus. I'm negative here. So that would be 180 minus 30, which is 150, and 180 plus 30, which is 210. So these 4 solutions are the solutions for x. Now, this lesson does have an 85 point B in the book, but we skip it. We don't cover it. So for your homework for 85, you're going to skip numbers 1 through 3, 8, 21, 22, 28, and 30. Thank you.